So hello, good morning. I'm Jan, and together with my colleague Dinesh, we will speak about embedded software modeling with Capital Software Designer. So if you have attended this meetup in the past, you will know our product already under the name SimCenter Embedded Software Designer. So this has changed, and we will change the presentation in the following way. I will give you an introduction to our domain and what the product basically does. And Dinesh will then explain how we take advantage of the MPS platform and share some insights that might be useful also for the community. So let's start first with what is Capital Software Designer. So we are addressing basically the fact that software is eating the world also in embedded in any products like cars or aircraft or any other gadgets. Some trends that lead to more complexity that also boils down in embedded software, very much driven by variance, boiling down to software variance, and the need to deliver high quality very fast, and also software taking more and more jobs that are safety critical, that used to be handled by mechanical means in the past, and we have seen in the talk from items before. So this is the problem space we address. We also observe that when you look at statistics, there is a variation of the relative cost for fixing software defects. So when they are detected in maintenance, it's very expensive, and the more you can front load the detection of software errors, in the ideal case towards the design stage, then you can have a smaller cost of fixing them. Unfortunately, a majority of software defects come from the design phase, so from improper requirements analysis and ambiguities, conflicts entering the design model. So our mission is basically to give users the tools to analyze, to create a rich software architecture and to analyze as much of that very early to make a correct by design software model. So looking at from a process viewpoint, the automotive SPICE model is still quite famous. What we address is the software architecture design and the software unit verification and integration testing. What we don't support is the implementation itself. So we are not a CIDE. For that you could use Embedded, or you could use Visual Studio and do hand coding. We do connect them to the level of software requirement specification, which could happen in an ALM or PLM system. So in-house we have the Polarion solution for that. And also in the end for creating the reports for certifying and qualifying the product, that's again where we connect to application lifecycle integration. And in the implementation space, we are open to whatever implementation technology a user wants to use. Many customers do part of their software in C still, in the C language, programming by hand. Some parts of the software in certain application areas are created in model-based paradigm using Simulink, for instance, with code generation, but you always have the problem in the end to integrate all these code artifacts into a consistent package, and also to combine it in the end with firmware operating systems, real-time operating systems, and drivers. So our core business is to specify around data flow diagrams, basically software architecture, and bringing enrichments like physical units, the software variability, contracts, which are basically pre and post conditions on the software blocks, the software components, and also specification of timing and resources that the solution may consume. As an outlook, we are also considering software quality specification as an early add-on. And the key point on the bottom here is that everything that should be specified should also be analyzable. So if it's not analyzable, we cannot detect the errors very early, and it's not helping with front loading. So where does the input come from? Input could come from upstream lifecycle stages in systems engineering. So we have integration with Autosar, SysML, and also ability to capture AADL models. And we also have integration with systems engineering modeler from the Capital product line. Also, we have capabilities to capture legacy artifacts that happen to be part of the of our customers' enterprise assets. Downstream, for the implementation, we produce then shell templates that which are code frames, basically a skeleton code, which gets filled by the end user, by implementers. This could be in the same organization as the architects. It could be a different supplier organization. When implementations are retrieved, we then check the interfaces, make sure it can integrate, and run verifications at different levels of integration, from the unit level to software integration, and eventually up to simulation in the context of a model of the physical environment of the embedded software. And then afterwards, basically the source code packages are deployed or shipped for further integration with a basic software platform. This could be in the context of Autosar, this could be in different contexts. Okay, and how do we now integrate into our new organization? So we are a part of Mentor Siemens Business now. The organization is called Integrated Electrical Systems. So classically, this segment has been dealing with electrical connectivity in vehicles, wire harnesses, modeled from definition through design to production and maintenance. And this organization is now also addressing embedded software, as well as network design, driven from an embedded system level engineering or architecture model. So we fit in right between this embedded system level, vehicle level architecture model, which considers ECU nodes, networks, and the signal exchange that is needed, as well as a very rough software architecture. Behind the embedded software design comes a network design and then the firmware stack configuration. And in parallel, you have then also products for the actual wire harness, as well as persistency. Okay, so that's us in a nutshell. And for the MPS aspects, I will hand over to Dinesh.
Now? Good. Myself, Dinesh Kumar Rajamani from India. The team is based on Chennai. We are more than a dozen people working with MPS every single day. I've been working with Siemens, in particular with MPS development environment for the past 5 years now. Last year I came here and explained how I fell in love with MPS. Maybe I'll go through about what happened in my love story with MPS in the last 1 year now. Time and again we say what we love in MPS and how we build MPS for our usage. What we love about MPS and is the editors and the transformation that it provides as a language workbench. In addition to the textual view that the MPS by default brings up with, we also present the user with several other views like SysML view and graphical other projections tailor-made for a specific user group. This is for the SysML user group, systems modeling language group. The Capital Software Designer being able to import architectures from other standards like SysML and AADL, we should allow the users to see how they see in their mindset. So this is not only a projection, this is more like a view tailor-made with several specific actions for the SysML group, specific context actions, specific toolbar actions. So this is just a screenshot from the demo model showing block definition diagram and the internal block diagram. This is another such editor used for representing C function called graph for one of our use cases. I have a demo video about this feature use case at the end of my presentation. So here, each node of the polygraph represents a function in C, and each edge represents a function called graph. This feature is used for transforming the legacy artifacts that the user has in the enterprise artifacts to a modern solution, model-based design. So I'll go through this feature in detail at the last. You could see in the inspector that we show the different color schemes for different functions. By default, we use Embedder's diagram framework from Shasha for building up block-based projection editing. The one which is there is for harnesses, stimuli and monitors connected to the control system, and this is typical block diagram. One addition here is we are able to project the witness results or the simulation results directly into the graphical projection that I thought would be interesting for you. How we exploit the generators? Mostly we generate C code out of the tool. We generate C shell templates for the user because we don't support implementation by default by now in the new positioning. We use Embedder for the IDE as an IDE. We also generate BNB simulatable codes, desktop simulatable codes, and the target specific C code. Being there in the tool chain, we need to interface with several other tools in the tool chain and other simulation tools like Simile. We generate a lot of XMLs as a standard data exchange format for interfacing with tools like Simulink and standards like Autosar. To also store the results from the tool as a simulation result and verification results, we do generate a lot of XMLs. Again, some screenshots from the tool. In order to explain more about the generated artifacts, we also ship in some generated HTML files, which shows what are the C files generated, where it is located, what are the function signatures, some validation reports like this, which explains what is really wrong in your model. This is another use case where we build MPS version controlled comparison for our needs. Being able to import from several standards like SysML and AADL for the same model, same architecture model, we should bring in the changes and show to the user what is the incremental architecture that is being imported into the tool. If architecture is already being imported into a model, and if the same architecture is from a different standard like Autosar being imported again into the same model, this pop-up automatically comes in showing what are the additional ports and parameters that has been added in the second iteration. So MPS being MPS models, we cannot compare as a text file outside the environment. We brought this dialog to compare the architecture inside the tool. This is another interesting thing that you could be looking forward to. The Graphical software designer do expose all the meta models and capabilities as an API, application programming interface. The user could write a small piece of Java program like this from any tool to read and write MPS meta models or MPS user models from any external application. This is another interesting topic. We developed this several years ago, but I thought it could still be interesting for the community now. Code coverage has always been a necessary thing for us in our tool to show that our unit tests are covering everything that we write as a language in DSLs. Graphical is a code coverage analysis tool in Java-based environments. We have integrated this into the DSL level to know what are the lines really get covered in our unit test and what are those that haven't got covered. What are the steps that we do is instrument the generated class files from generated content from MPS in the JavaCo environment. We execute the test using the instrumental classes, lift the results into MPS and show to the user or to the developer what are the lines that are not covered. This we have built as just for us, for our internal needs to know. Here you could see that several lines have been covered already by the unit test and several lines are not covered. We also work to a little bit into the build scripts. We created a plugin called Code Coverage directly integrated into the MPS build environment. This generates a small hand task like this, which calls the JavaCo instrumentation. This has been already integrated in the Jenkins environment, and the results have been projected in the Jenkins directly. Anybody from the technical management or the product management could really look into the coverage results directly. This is the use case that I was talking about. Extraction of architecture from the C legacy artifacts that the user is having. The user contains a lot of C legacy code in his project that he has been hand coding or generating from other tools for the last 10-15 years. He does not want to take or lose all the IP or intellectual properties that he has been having for several years. He might want to transform this into model-based design. We brought something called the C project configuration where you could specify what is the C legacy artifact that you want to bring it into the tool as an architecture, data flow architecture. Now we are importing that into the tool. In the left hand side, you could really see the entire C project as a visualization, all the C and H files and the functions, everything. This is the call graph that I was talking about, which shows all the functions and the function calls as a directed graph. The arguments and the different types are shown here. Some of them are pointers and some of them are non-pointers. If they are pointers, we decide how to bring them in as input or output. After marking everything, we can import this particular call graph or the legacy code into the tool as architecture, data flow architecture. Now we invoke the context section to import into the architecture. We have been presented with the option to choose a model in which we need the data flow architecture. Now we really do some processing to bring the call graph into the model as the architecture. As block diagrams, the complete function call graph has been transferred into block diagrams into data flow things. This is being externally referred to the original C code. This is an implementation configuration which maps what is being imported, and we also show some reports with proper comments on what is called to the original C code. We also bring in all the types that the user has in the legacy code. A lot of type diffs and the user different types will be there. We do not want to lose them. We also bring them in as external modules. Yeah, this is one use case that I thought would be interesting for you. How we really use the MPS editors and the transformation capabilities to achieve our use case. Yeah, that's it from us today. We are open for questions.
Questions? So you're currently doing the step from embedded software designer to capital software designer.
Yes.
I understand it right.
Yes.
And most of the things you have shown are somehow related to the C language.
It is still an embedded software designer. It's just just the name is known from the brand name because that's kind of implicitly clear. But it's still an embedded product.
So what does capital mean?
That's a product line name.
Okay.
Is it possible to import other languages like Kumar?
It's a good question. So currently we also support Siemens.
But it's
Could be. Yeah, so this is driven by demand. So wherever is needed, we can do. We are not limited to any particular programming language.
It's no longer just embedded software, so it can be global.
Thank you.